Thank you for inviting me to present today. It really is an honor to be able to talk at an event like BIF. And thanks for being in this session today. I'm going to be giving some recent developments on a research project that I'm working on related to a genetic analysis of gas fluxes as well as metabolic heat production. So just so that everyone's on the same page here, starting out with a brief introduction, enteric fermentation is a normal natural digestive process of ruminant animals, and this is what allows them to be able to upcycle forages that are not edible by humans into a product that is, so high quality beef. So in that process, though, methane is produced as a byproduct, and it is released from the animal two ways. And this will be important later on when we talk about the ways to measure it, but mostly it's coming out in eructations, but a small portion comes out the other end. And then just some more background stats and information. So methane is the second most abundant greenhouse gas, and it's well below carbon dioxide. But when you look at it by source, enteric fermentation is about 25% of the methane emissions in the United States comes from enteric fermentation. And really when you break it down, and it really has an impact on sort of all three areas of sustainability. So defining sustainability and thinking about that related to social, economics, or the environment. Socially, that would be the resilience of rural communities, availability of quality and nutritious foods, consumers' perception of beef production. Economically, this is really a key point here, is that it's an energetic inefficiency when you produce methane in that process. It's a loss of 2 to 12% of the gross energy. And so that portion, instead of going towards a process that would be beneficial, such as lactation or growth or things like that, it's a loss, and it's going towards production of methane. And then we already touched on the fact that it's a greenhouse gas and accounts for 25% of the emissions in the US. And as I kind of mentioned in the title, we're going to be focusing in on grazing beef cows for this. And that's because grazing beef cows, they're the largest contributor out of the whole life cycle. So this is a graph here from the Rotz and others 2019 paper, and they break it down by source, but then even total emissions. The cow-calf or grazing sector in the green constitutes the largest portion there, well above stocker and finish. And that's for a variety of different reasons too. For like one of them would be diet. So they're consuming a forage-based diet, which is known to produce greater methane emissions, as well as they're spending the majority of their lifetime in this phase. And there's the largest animals in this phase. So it's not really an area of low-hanging fruit. It's not easy. But as far as making a difference in the total beef life cycle and span on the beef industry, this is the area that has the greatest opportunity. And there's obviously pressure coming from a lot of different places to reduce emissions. There's the Global Methane Pledge, which is a pledge that a variety of different countries, the US being one of those, made to reduce methane emissions by 30% from 2020 to 2020, from 2020 to 2030. And so we're obviously halfway there. That's coming up quick. Within the beef industry, a variety of different organizations have made pledges. So there's the U.S. Roundtable for Sustainable Beef, National Cattlemen's Beef Association, pledging to reach climate neutrality by 2040. And then a variety of different companies within the private sector have also made various pledges, both within the beef industry and agriculture and beyond. But how are we going to get there? This is some tables that I've adapted from a Bookhuman and others paper. And really, I'm not gonna talk through like all of these different strategies, but a couple of things to point out. We have this table, which would be the strategies available for confined or partially grazing systems. And then this table would be the strategies available for grazing systems. And so, number one, you can see that there's obviously far fewer strategies available to the grazing sector as far as mitigation. And then, each of these strategies has their own trade-offs and efficacies and challenges associated with them. But what we're going to be focusing on for the remainder of the presentation here is the selection for low methane producing animals. And so as far as that goes, selection and genetic changes, those are permanent and those are cumulative over time. And so we don't have to, feed a feed additive from now until the rest of forever to get the changes. They're permanent and they accumulate over time. Literature is somewhat limited in this area, particularly as far as genetic parameters. But the estimates that are out there suggest that absolute methane production in beef and dairy cattle is moderate, so ranging from about 0.2 to 0.3. And then once again, this is really one of the few strategies that can be applied to extensive grazing situations. But like I mentioned, each of those comes with their own challenges and things that need to be addressed. And so there's some possible unfavorable associations between methane production and productivity in genetic correlations that have been published before. And then the phenotype collection on a scale large enough to be able to incorporate it into genetic evaluation is another challenge. The project that I've been working on and what I'm going to be presenting as far as data today comes from the green feed pasture system. This is made by a company called CLOC, and this is just like their mock-up basic design of what it would look like. But it's their units and it's just mounted on a bumper pull trailer so that you can take it out into pastures. And then this is a diagram of sort of how the system works more technically. But basically the animal will approach the system and their incentive to do that is the feed that drops down into the feed dish here on like the other side of the screen board. It reads individual RFID tags, and when that happens, some fans turn on and start pulling the air into the system. And so the background air, as well as anything that animal is emitting, is captured and pulled into the system and then quantified. Some more pictures of what ours looks like. Excuse me. So this is the feed that I mentioned. It's alfalfa pellets, and there are a variety of different settings that you can program and sort of control in a way how much is released, but the amount that comes down is pretty small, especially in comparison to their total diet. The basics, it's basically just used as an incentive to use the system. And then ours has the two units mounted side by side on the same trailer. And we did that just to sort of allow for larger contemporary groups, knowing that genetic evaluation was the goal. And then there's cattle panels around the system to prevent animals from getting into the stuff they don't need to be getting into. And it's powered mostly by these solar panels. We also have a generator as a backup source. And then you can sort of see the two systems there side by side of what it looks like as the animals are approaching. And then this is a slide I put together just sort of to pose some general questions and thought-provoking questions for the group. I definitely don't have the answers to all of these questions, but right now we have the BIF guidelines that I was fortunate enough to be able to put together and be a part of that. And that has the information that, we know today, but there's definitely a lot of things that need to be addressed. The first one there, what equipment are we gonna use? Today, and what I have experience with is the green feed, but, as far as data collection on a large scale, there's benefits and trade-offs to lots of different things. Probably is not gonna be respiration chambers as a possibility, but what else is out there and which one would be the best for that? And then after that, how do you use it, and what's a standardized phenotype collection protocol? We have that down for the green feed a little bit more, and I'll get into that in a couple of slides. Collection at what age? So there's obviously a variety of different places along the life cycle that this could be measured. Heifers, cows, the feedlot, and so where are we doing that, as well as in the production cycle? Are these lactating animals? Are they calving animals? Or are they not? Which one is the best? So, or do we need to even worry about that at all, I guess? I mentioned the protocol development a little bit. This was a paper that we published in 2023 just to sort of think about this question, the minimum number of spot samples required. So our green feed measures methane, carbon dioxide, and oxygen, and then metabolic heat production can be calculated from those three gases using the Brouwer's equation. And I won't really spend a ton of time on this, but basically, prior to this, a lot of literature had focused on the length of the trial in days, but knowing that that can fluctuate and the number of visits each animal makes in that time period can be pretty variable. Thought there might be a better way to look at it. So we had animals at the very beginning of this trial that had over 100 visits. And so we looked at those animals specifically and created intervals for their visits in increments of 10. So we calculated their mean gas flux and metabolic heat production at each interval. So the mean from the first 10 visits, the first 20 visits, and so on, both in the forward and reverse direction. And then we calculated the correlation between the mean at that interval and then considering the full 100 spot samples as the gold standard there. And then when that correlation was above 0.95, that's sort of when we decided that was the recommended number. And after that, narrowed in more specifically at the range between 30 and 40. And this is just briefly the results from that. So we have the three different gases that I mentioned, as well as metabolic heat production. That black line would be the 0.95 correlation cutoff I mentioned. And then we see that at about 40 visits, that was the recommendation that we made. All of these gases and everything are collected at the same time. So if you get 40, then you're kind of capturing everything else along the way. So that was the recommendation. And since then, there's been a variety of other published literature on this topic. And there's some differences in the animals and the conditions, but mostly are sort of in the same range of agreement. So this was a study from confined conditions and growing cattle and recommended 40 visits, a few more needed for methane. Differences there just because these are growing animals, and so that could be fluctuating and changing more over time. And then growing steers, but this time in grazing settings, needed a few more visits, depending upon the gas. And then the other sort of part of this conversation has been whether to consider visits that are 2 minutes in length or 3 minutes. The study sort of validated our number. We did it with 2 minutes and got 40, but if you're taking only visits that are longer, you might need less. So like I mentioned, the protocol side of things, particularly for the green feed, is becoming a little bit more hashed out, but still some questions to answer there. And then on the other side of the question that I posed. The next one would be when to do this. And so our study was definitely not designed to answer this question, and that wasn't an objective for us, but just based on the data and opportunities that we had, this was some stuff that we were able to pull out and think about. So this would be animals that were tested on 2 different groups. So there were 30 animals that were tested in group 1 and then tested again in group 4. And then there was a different 30 animals that were tested in groups 2 and 3 as well. And so in the green, this comparison would be about a year's difference in time, but some differences in diet and supplementation between the groups. And so this is their correlation between their average in the first time they were tested with the second time they were tested, so about 0.45 there. In the blue, we have sort of following animals through a little bit of the life cycle here, so some from the summer into the fall. These were fall calving heifers, and so in their second time, they eventually calved and began lactating. So the correlation there is actually a little bit higher in the low 0.5s between the 2 times they were tested. But like I mentioned, it wasn't designed to really answer this question, but just some things to think about. We can't really parse out, what the difference is due to time or the diet or, some confounding factors there. But these are the correlations with the results we have and some things to think about as far as when animals should be tested. And so since that first sort of results on the protocol that I presented, we've continued to collect data pretty continuously since then and building up the phenotype data collection that we have. This is just the summary statistics right now for animals that have at least 1 visit. So that's 340 animals right now. And last week, we recently ended a trial with a pretty large group of animals, and that's putting our total animals that we have data for over 400 right now. So an ongoing process, but getting in with some larger groups and just continuous data collection to build those numbers. And I'll be presenting some preliminary heritability estimates and things on the 340 grazing animals that I mentioned on the last slide. So there was 340 animals with phenotypes with 2,766 visits total. And AGI provided the 5-generation pedigree for those animals, as well as the genotypes for the pedigreed animals, and then all of the animals that were in their pedigrees. And so there ended up being 4,926 animals total in the analysis. And I won't be presenting any results that have been done after more official model testing, but what I will be presenting today would just be some preliminary estimates from a univariate animal model. So we had animal as a random effect, and then green feed testing group sort of as the contemporary group there. Like I mentioned, this has been continuous data collection, so there's been about 11 different groups that were fit there. And so these are the preliminary estimates. I want to sort of stress that once again, they're preliminary, but what we have right now for that group of animals. So this is average methane per day in grams, CO2, oxygen, and metabolic heat production. The estimate here coming in pretty well in range with what we've seen from other literature, so 0.21. These other 3 traits are more novel and honestly not a whole lot of literature to compare those estimates to. But recognizing somewhat of the large standard errors there and just coming back to, having a pretty small data set for that and trying to get more data over time. But This is sort of preliminarily what we've got, and it's looking promising. In the future, so obviously continuing to collect more phenotypes. This is somewhat challenging. It's time consuming and expensive to do. Occasionally there's malfunctions with the equipment that might set you back on your timeline a little bit. But right now we're moving forward with the heritability estimates that we've got after more complete model testing, as well as exploring the genetic correlations between those gases and then the genetic correlations that they have with other production traits, and then a QTL analysis. And then another sort of just thing to think about would be, we talked about the protocol and recommending 40 visits. So those with less than 40 visits would somewhat be considered incomplete. But this is a table that shows the phenotypic correlations between animals' first visit. So they're only visited at one time, their first visit, with their average after the 40 visits. And so there's 208 animals that had over 40 visits to be able to calculate this with. And their correlations are still pretty high, so 0.5 to 0.6. So that's just with one visit, being a pretty good indicator of their average after 40 still. And so with that, I'll acknowledge the support we've had on this project, partially from the NAB Doak Fellowship that I received in my master's, the Angus Foundation, which is an affiliate of the Angus Association. We've had 2 different companies provide feed for this project, which has helped out a lot, Countryside Feeds and Pellet Technology. And then, of course, our breeder partners in helping us with having access to animals to do this. The K-State Purebred Unit, Dr. Dave Nichols, Dale Banks Angus, Matt's here, and Mercury Angus Ranch. So thank you to everyone on that list. And with that, this is my information. If you have future questions or want to reach out, but I can take some questions now too, so.
Do we have any questions?
I just have a quick one. I noticed that there's higher correlations between like the first visit and the average between 40 than the ones that are separated by season. Is there a reason for that, you think, or it just changes more?
Let me think about that. So the question was, the averages between the first visits and then the first one between the groups would be their average from the first time they were tested, and then the average from, say, the second time they were tested. And so I think with that, it just comes back to sort of those questions that I was posing about differences in diet or forage quality in those times, or some of them were different points in the production life cycle. And so that seems to be having an influence there. But like I mentioned, our study wasn't particularly designed to answer that question specifically. I think you would need to sort of design an experiment that would be able to parse out the effect of each of those factors to be able to answer that a little bit better, but yeah.
So, I enjoyed your talk, thank you. Methane is influenced by intake and also by font size. Look at methane intensity, grams of methane per unit of body size.
So yeah, methane intensity, there's a ratio trait, so it'd be methane production over their product, so it could be weight or calf weaning weight or things like that. So we haven't gone that far into defining some of those other traits. There's, you know, ratio traits or residual traits and things like that. In the, you know, BIF recommendations that we had, we sort of said is sticking to those absolute traits instead of selection for ratios or residuals is probably the better way to go. But yeah, other people have looked at that, and we don't have that in the current data set yet.
Let's
Yeah.
application standpoint or applied standpoint, what's the largest group that you feel like you can put one feeder in, and what's the shortest days where you get good data, and does that decrease as you have more head on there?
Yeah, so Matt's question's about capacity in a group, basically, so, ours is a little bit different, it's one of the only ones that's set up with two of them on the same trailer. And so that allows us to do some larger groups, we've been with groups that are around 150 head now, but there's some other factors that play into that, so pasture size is obviously a lot larger to be able to accommodate that group, and so with that, they really visited a lot less frequently, and that extended the amount of time we had to be out there, so there's definitely some trade-offs there.
To go along with that, you know, what's it going to take for us to get these measurements on thousands, tens of thousands of animals?
Yeah, so just what's it gonna take to get enough phenotypes? I think, it probably is not gonna be like an individual effort. There's definitely needs to be collaboration and a lot more collaboration between, a lot of universities now have green feeds. And so I think we need to get together and start to have some conversations about how we can pool all of the data that we do have, because it's expensive to collect and it's difficult, and so we need to use everything we have.
Maybe I missed this part, but when you estimate heritability, do you use a single record or do you use the repeated measurements?
Yeah, that's a good question, or his question was whether we looked at a single measurement or repeated records, and so we're doing both. The estimates I presented today would just be their average, so the single record, but repeated records is on the list of things to do as well as some other methodologies, so. Yeah.
And being out on pasture, is there a certain time of year that works better to report it? Because, you know, grass coming in, does that change just with the measurements as well? And how many times the house?
Yeah, that's a good question, so about timing of the year and, so I think there's a couple of things to think about there as far as, the changes in that and forage availability and its effect on the estimates itself. But then I think your question too was about animal visitation, and I think we haven't tested this specifically with stats to tell you, but I can tell you just from working with it that, in the summertime where there's lots of fresh green grass available for cows and it's really, really hot, at least in Kansas, animals are not incentivized to visit the green feed as frequently or as like spaced out during the day, so they may alter their visitation patterns to be more in the morning or the evening when it's cooler, and so that may have an effect on things as well.
You know, could you put a shade on?
Yeah, and placement of where you put it is important too. If it's definitely should be near a water source or a mineral source where animals are gonna be at least in that area sometime during the day. Yeah, if you have shade, that'd be even better.